Hi, this is Mrs. Kidman, and in this video, we are going to be covering average rate of change when we're given a function in the form of an equation and the interval that that's on. So a reminder, average rate of change is how much a function changes per unit on average over an interval, and it's derived from the slope of the straight line connecting the interval endpoints. So in the last video, we talked about how we can calculate that when we have a graph here. And again, that's this straight line here. And we talked about how we can count that rise over run to determine what our average rate of change is. In this one, we're going to be given a function and using the interval that we're given for our x values, calculate what that rate of change is. So the equation we're going to use here is going to be the average rate of change, or AROC, equals f of b minus f of a over b minus a, where a and b are the two endpoints of our interval. So let's take a look at this first one. So here we are trying to find the average rate of change of the function f of x equals x squared minus 3x plus 7 on the interval from when x is 2 to when x is 5. And so this interval gives us our endpoints. So this 2 is a and 5 is b. What we need here is we've got b, we've got a, so I'm going to write it over here. We've got our b and our a, right? We've got 5 minus 2. But really what we need now is we need to figure out that f of b and f of a. And the way we can do that is our f of a is going to be everywhere that our a, which is 2, goes in for x. So let's take a look at that here. So this is going to be 2 squared minus 3 times 2 plus 7. And that will simplify to 2 minus 6 plus 7, which actually ends up giving us a 5. So this 5 is our f of a. So I'm going to put in for f of a the number 5 here. Now let's figure out what f of b is. So f of b, remember b is 5, is going to be when we substitute 5 in for x everywhere. So we've got 5 squared minus 3 times 5 plus 7. And that's going to be 25 minus 15 plus 7. And that simplifies to 17. So that makes this value over here 17. So as we simplify this, we end up getting 17 minus 5, which is 12 over 3, which equals 4. So the average rate of change, or the slope, from 2 to 5 of this function is going to be 4. And that's kind of what we're doing here. So let's take a look at this next one altogether, and let's do that average rate of change again, the same thing. So remember, the first one is A, the second one is B. So as we're calculating our average rate of change, let's just substitute those in while we know them. So 3 minus negative 1. Now remember, a minus and negative, we want to change, and we can make that minus negative a positive because that is that rule. So we are going to change that right there to give us a positive. Fantastic. Now we need to find f of a and f of b. So f of a is going to be when we substitute in negative 1. So we have negative 1 squared minus 4 times negative 1 plus 10. So let's go ahead and simplify that now. Negative 1 plus 4 plus 10. Well, that simplifies to 13. So f of a is 13. And then we need to find f of b, which is going to be when f equals 3. So let's substitute 3 right into our equation. So negative 3 squared minus 4 times 3 plus 10. And then we want to simplify this. So we get negative 9 minus 12 plus 10. And that will simplify to a negative 11. So this is negative 11 minus 13. Now let's simplify this problem and see what happens. Negative 11 minus 13 is negative 24 over positive 4. And that will simplify to 6. So our average rate of change is 6 for this function f of x from the interval of negative 1 to 3. Now, I want you to try this next one all on your own, following that same process. So remember, this first number here is a, our second number here is b. We want to substitute that in to our equation here, our formula, and then we need to find what f of a is and what f of b is. So go ahead and pause the video, find those solutions. When you finish, unpause the video, and we will go over what those solutions are, how we find them, and what that average rate of change is for the function 2x squared plus 5x minus 4 on the interval 0 to 4. Okay, hopefully you've had a chance to go over this problem on your own. So remember, we have a and b. When we found f of a, that would be f of 0. So 0 goes in for all of the x's, and that simplifies out to negative 4. Now, f of b is going to be when x equals 4. And so everywhere there's an x, we need to do 4. A common mistake that people make when there's a number in front and an exponent is they like to do 2 times 4 squared. But remember that we have to follow our order of operations here. And so we do need to do 4 squared, which is 16 times 2 to get that 32. So we end up getting 48. So then as we substitute that into our average rate of change equation, we get 48 minus -4, which really is like plus 4, divided by 4 over 0. And that simplifies to 52 over 4, which is 13. So that's how we find the average rate of change when we're given the equation of a function, as well as the interval that we're looking at it. We're going to use those a and b points, those endpoints of our intervals are a and b, and we're going to substitute it in to that f of b minus f of a equation. Now, come check out the next video in which we discuss how we can do these average rate of change problems in an application sense or with a word problem. So I hope you check out the next one. Thanks.